and in this time the change of variable is going to make the region a lot simpler. We've done a few that we made the integrand a little bit simpler. So in here we're looking at a region that is bounded by xy equal to 1, xy equal to 4, y equal to x, y equal to 2x, and integrand is fairly easy to do, and then we're asked to find this integral and over this region basically. And so what I notice is that there is the x and y between 1 and -1, and y over x between 0 and 2. And it seems like this could work for me in this situation. I also notice that if I multiply let's say xy to power 2 times y over x, then I get that integrand up there. So it looks like a good option for change of variables. So let's see, if I use this as u and use this as v, would I get the right region basically. So before I always looked at the integrand and I chose something. In this case I'm looking at the region and I'm choosing u and v. And so in here again I will have the inverse, that is g inverse of x and y is going to be u and v, which is, I chose u to be xy and v to be y over x. And now can I find what g is? Yes, if you basically if you want to solve for x and y over here, this is u, this is v. So if I multiply u times v, what I get is going to be xy times y over x, which is y squared. So y is equal to, and I know we're on the positive side, square root of uv. Then I can use this to actually solve for x. X times y is equal to it's equal to u, and I know y is square root of uv, so I eliminate and I figure out that x is going to be equal to u divided by square root of uv, which is x is equal to u to power 1/2 v to power -1/2. And so that's my transformation itself. So according to the choice of, we chose u to be xy and v to be y over x, and therefore let's see, u to be xy, and xy is supposed to be between xy is supposed to be between 1 and 4, and so that makes u between 1 and 4, and we said v is equal to y over x, and v in here is let's see, that in here, for example, y over x is equal to 2, this one y over x is equal to 1, so v is between 1 and 2. So that's my region, and it's rectangular. And so we figured out g as well, and as well as g inverse. Now I would like to find the Jacobian. This is Jacobian of g, because I solved for g. Again, you see, so I'm basically finding x with respect to u, and I'm finding x with respect to v, and then y with respect to u, y with respect to v, and I get 1 over 2v. So the integral that we saw in the beginning converts to these bounds, and then by then the other thing that we have over there is that the integrand that we have to resolve, and we found the Jacobian, and v is always positive, therefore Jacobian is positive. The order of u and v follow from what they're supposed to be. Now, integrand in the original was x y to the power 3. If I use what I have here, that's x times y to power 3 half, I will end up with u squared divided by u squared v. And then divided by 2v, I get u squared divided by 2, and integration.